Okay, so now we have Alexandre Nuttinck, who is a DevOps team lead at iMio, and he's going to talk about multitenancy in Odoo.
Thanks, Alexandre. So, good morning, everyone, and welcome to my presentation on multitenancy in Odoo. So, my name is Alexandre, and like Alexandre said, I'm the DevOps team lead at iMio, a public company based in Belgium. And today, I will not talk about the Lord of the Rings, sorry, but I will share our journey implementing multitenancy in Odoo, a topic that I discover lacks proper documentation and examples. For your information, I discovered Odoo some years ago, but I really got involved with Odoo and the OCA only about 2 years when I started working at iMio. Since then, I think that we've been pushing the boundaries of what's possible with Odoo in production environments. Now, let me give you some context about iMio to understand why multitenancy was crucial for us. iMio is a public administration that provides IT services to local authorities in Wallonia. We serve around 400 local authorities, including municipalities, public social action centers, provinces, police zones, rescue zones, and so on. We manage 11 different applications with over 1,200 instances. And our mission is to mutualize and organize IT solutions and best practice for local authorities. So today's agenda will take us through our complete journey with multitenancy. We start with the story of iA.Vision, our project management application, which uses a multi-tenant architecture. Then dive into what multitenancy actually means, why I felt compelled to give this presentation, then how it works technically in Odoo, the architecture we set up at iMio, and finally the pros and cons with experience. And I leave time, I hope, for questions at the end. So, this brings us to iA.Vision, the project that starts on multi-tenancy adventure. So it's our project management application, specifically developed for public administrations. It's built on Odoo 16, and we're migrating to 18 next month, but it's another story. It handles operational management of all projects within local authorities. And here's the spoiler and the subject of this presentation. It currently serves 78 different tenants or local authorities in a multi-tenant architecture. The project is open source under GPL v3 and is officially referenced in the European Commission's catalog. So you can scan the QR code to see more detail about our project. This is the story I want to share with you today, how we went from 0 to 78 tenants and what we learned along that way. Maybe I'll let you a sec if you want to scan the QR code, but it will be shown later, so don't worry. Now, before diving into our implementation, let me explain you what multitenancy actually means. Multitenancy is a software architecture where a single instance serves multiple customers, called tenants. All tenants share infrastructure, code base, and database, but each is logically isolated with their own data. Think of it like an apartment building versus individual houses. Multitenancy is the apartment building where residents share common infrastructure but have private spaces. And the diagram on the slide illustrates this, showing how multiple tenants coexist on a single platform when maintaining independence. And for our 78 local authorities, this means they all run on the same Odoo instance, but they see actually their own data. So knowing what multitenancy is, Let me tell you about the decision we faced. At the conception of iA.Vision, we had a critical choice. Should we deploy separate Odoo instance for each of our clients, or should we implement a multi-tenant solution? And given our budget constraint in public sector and our DNA of mutualization, multi-tenancy was the logical choice. But it wasn't so easy. We knew we'd be venturing into uncharted territory with limited documentation. And this decision would shape everything that followed in our journey. And this brings us of why I'm giving this presentation. When we start our multi-tenancy journey, we faced a significant challenge, the documentation gap. I was like the kid. Odoo's official documentation only covers the DB filter parameter briefly. There has been also an open GitHub issue since 2019, which is not closed, of course, requesting better multi-tenancy documentation. And clearly, we are not alone in this struggle. The community has been asking for practical guidance and real-world examples. And after more than 1 year of learning the hard way, serving 78 tenants in production, I feel compelled to share our experience. This presentation aims to fill that gap and hopefully save you some of the trial and error we went through. Now, let's dive the technical heart of how multi-tenancy works in Odoo. The good news is that Odoo has native multi-tenancy support through its database architecture. Each tenant gets their own database on the same Odoo instance. And the magic happens with the DB filter parameter, which determines which database to use based on the incoming request. The diagram shows how this works in practice with URL-based routing. So for example, each of our 78 municipalities get their own subdomains like Liège, iA.Vision.iMio.be, for example. And yes, the technical implementation revolves around key configuration parameters. The DB filter uses a regex pattern which represents the subdomain, like I said, ensuring proper routing. We set DB name to false to enable the filtering mechanism. And yes, there is also a good OCA module that we don't use at iMio, which is a DB filter from header, in cases where databases can't be mapped to subdomains. So we don't use it, but can be very helpful. And critical consideration include memory management per worker, database connections limits to overwhelming PostgreSQL, and proper session handling to maintain isolation between tenants. Let me a sec. This brings us to our production architecture at iMio. So we built it on Kubernetes, the container orchestrator for scalability and resilience matters. And for your information, Adrien Pfeiffer presented about running Odoo on Kubernetes last year. And when I saw his presentation on YouTube, I said like, okay, it confirmed that maybe we hadn't made so bad choice. So I don't know if he's here today, but thank you, Adrien, and I recommend you to watch it if you want to know more about why and how to run Odoo on Kubernetes. So currently, we run 3 Odoo replicas behind Nginx reverse proxy that handles SSL termination and load balancing. We use PostgreSQL, which is managed by the cloud-native PostgreSQL operator, providing replications, backup, and point-in-time recovery. We use also MinIO for S3 object storage, where we store all attachments like PDF and so on. ensuring us that they work across all replicas. And for that, we use the OCA FS storage module. And also the sessions are stored in a PostgreSQL database rather than in the file system. And for that also, we use the session DB module from the OCA. So thanks again to the OCA for these very useful modules. And yes, this architecture allows us to serve 78 tenants with high availability. For instance, if we lose at a certain time a Kubernetes node, and it already happens, the system recovers quickly without downtime. Most importantly, it scales horizontally. We can simply add more Odoo replicas when usage grows. Now, let me show you the actual configuration that powers our 78 tenants. These are our battle-tested production parameters. The DB filter configuration is crucial for proper tenant routing, like I explained before. We run 12 workers across 3 replicas, which in theory, giving us 36 simultaneous clicks and supporting around 216 connected users, according to the Odoo documentation. Memory management per worker prevents one tenant from affecting others. We set both soft and hard limits. Database connection limits are critical. We limit each worker to 10 connections to avoid overwhelming PostgreSQL. In fact, we should have set this limit a bit higher, like 20, as it is based on the number of workers and replicas. And like I said, sessions are stored in PostgreSQL rather than the file system to support multiple replicas. And the beauty of this configuration is that it's flexible. We can just adapt these parameters dynamically based on the usage patterns. And for that, we use Prometheus and Grafana to monitor the performance across all replicas and identify when we need to scale. So this configuration has served us well, one year of production use, but we are ready if we need to adapt it. After more than 1 year running 78 tenants in production, let me be honest about what we have experienced, both the wins and the challenges. On the positive side, the economy of scale is real. Our infrastructure costs are much lower than running separate instances. Maintenance is simplified with a single code base, and updates benefit all tenants immediately. Resource utilization is efficient, and new tenant onboarding takes only minutes. But multi-tenancy isn't a silver bullet. Customization becomes complex for tenant-specific features. Performance can be impacted if one tenant consumes excessive resources, even if our Kubernetes architecture helps mitigate this. Security isolation is critical, and if vulnerability could affect multiple tenants. Database schema updates are particularly challenging since each of our 78 tenant database needs individual updates. And troubleshooting can be more complex when isolating issues while maintaining service for others. The key is to understand these trade-offs and before you start your journey with multi-tenancy. Speaking of database updates, let me share one of our biggest operational challenge. So upgrading 78 tenant databases. For that, we have 2 distinct paths, depending on whether database schema changes are involved. For code-only updates, we'll leverage Kubernetes rolling deployment for 0 downtime. Users don't even notice the update happening. as we are updating one Odoo replica per one Odoo replica. And of course, this works because all the tenants share the same code base. However, database schema updates are more complex, and this is where our lessons learned really shine. We start with comprehensive pre-flight checks, including point-in-time recovery backups and database health validation. Then we use Kubernetes jobs with parallelism to upgrade multiple databases at the same time, which is absolutely critical when you have so many databases to upgrade. The YAML file example shows our actual job configuration. We set up 78 completion with parallelism of 10, meaning that 10 databases are upgraded at the same time. And during these upgrades, we enable maintenance mode, which scales all the replica to 0 and shows a maintenance page to our users. Our cloud-native PostgreSQL setup provides point-in-time recovery, so allowing to roll back individual database if needed. And at this time, the entire process takes 15 minutes for all 78 databases. This might seem complex, but it's essential for maintaining service quality across all our tenants. So, the big question everyone asks, should I use multi-tenancy for my use case? Well, it depends. Based over 1 year experience running many tenants in production, here is my advice to help you to decide. So multi-tenancy is fantastic when you have multiple similar customers with shared requirements and budget constraints. Exactly our situation with local authorities in Belgium. All our municipalities need the same core project management features, so multi-tenancy is perfect for us. It's ideal for centralized maintenance, quick onboarding, and cost optimization. However, I strongly recommend considering single tenant deployments if you need heavy customization per customer, have strict compliance requirements demanding complete isolation, or face unpredictable resource usage that could impact other tenants. Also, if your customer needs, of course, Odoo version, different Odoo version or vastly different integrations, single tenant might be better. The key is being honest about your constraints and requirements. Don't choose multi-tenancy just because it sounds cool or because it should cost lower. Choose it because it fits your business model and technical constraints. This brings us full cycle to why I'm giving this presentation, giving back to the community that help us. We believe in contributing to the ecosystem that supports our journey to multi-tenancy. First, we open source our Helm chart for deploying Odoo on Kubernetes, which includes our multi-tenancy configuration. Feel free to use it. It's under Apache license, or to fork it. Our iA.Vision project is completely open source under GPL v3. And we continue supporting the OCA indirectly through sponsorship and development, but we would like to directly contribute to some modules in the next month. We are working to document our multi-tenancy setup to fill that documentation gap we encounter at the beginning. And this presentation itself is part of our effort to share practical real-world experience with the OCA. And we want to help others avoid the trial and error we went through. Looking ahead, we have several exciting development planned. Next month, like I said in the beginning, we'll be migrating from Odoo 16 to 18 using the OCA Open Upgrade project. This will be our first major version upgrade in our multi-tenant environment. So we're preparing and testing the process at the moment. We are also implementing SSO integration with Keycloak to provide centralized authentication across all our clients. We would like to optimize some performance using database with replica, which is available in Odoo 18 and Nginx configuration improvements. And we want to enhance our monitoring with direct metric collection from Odoo instances, like how many users are using the project, how many projects they create, and so on. And like I said before, we want to contribute more open source tooling and documentation back to the community. So thank you for following our journey. I hope our experience, thank you. Thank you. I hope our experience will be helpful and will save you some time. So, have you got any question?
Thank you very much.
Thank you.
Thank you for the talk. I had a question. You mentioned point-in-time recovery.
Yes.
It's for the full database cluster, or
yes,
you
it's
don't
for
have
the full cluster.
Yeah.
So if it's needed to roll back to the entire cluster, it's possible.
So for all database, so there is no other solution.
We have all the database, so if we need to roll back only one, it's possible.
Yeah, of course, of course. And another quick question: can you show again the job that does the upgrades?
Yes, of course.
How do you tell the job which database to upgrade so they run in parallel?
There, the init container,
okay,
which is not shown. Because I don't have any. I'm missing some space on the slide, but it's a static list of all the tenant names. And so the init container choose one of the tenants and give the tenant to upgrade.
Okay, cool. Thank you.
Yes, thank you very much for doing this. And one question, how big is your operations team? I mean, how many people do you have that are familiar and can run the cluster and this thing? Just rough size.
We have 3 sysadmin that set up the Kubernetes cluster and so on, with the help of course, of an actor, a French actor, to set up this. And for the Kubernetes part, I think we are 2 or 3 that can handle this.
And you're still convinced this multi-tenancy is superior to running single instances, because this is always, very crucial thing. For example, like maintenance windows, if you would have different maintenance windows for different tenants, you'd probably...
Yeah, but...
you don't have it, so...
Yeah, we don't have it. The idea is to have a common maintenance for all our clients. Okay. And yeah, the point is to have a single code base. It's very important for us. So all the new features will be for all our clients.
Yeah, that's okay. Thank you.
How many users normally does this cluster handle?
Like I said, okay, it's in theory, but I don't have the numbers in head. But
like
I know
approximately
that
100, 200, 1,000?
Yeah, like 1,000, I think.
1,000?
Yeah.
Thank you.
Any other question? No. Right. Thank you very much.
Thank you.